Hello. So apologies first off if my fan is a little bit loud. It's very hot in here. Okay, so the problem I chose, a 28 kilogram, 3.8 meter piece of scaffolding is supported at both ends. A 48 kilogram painter stands 1.2 meters from the left support. What upward force does the right support supply? So here we have the diagram. So this is all about static equilibrium. So we can make a few assumptions that the torques counterclockwise and clockwise have to equal each other, and then the sum of the forces both upward and downward also have to equal each other. So we're looking for the right support, so we're notating that as F of R, and then we're saying that our left support is the pivot point, so that means that the left support torque is 0. So a couple of our knowns and some equations to use. We have the mass of our scaffolding, which is 28 kilograms, the mass of our painter, which is 48 kilograms, and then we're saying that G is about 9.8 meters per second squared. And then we have our torque equation, which is the force times the distance, and then our force equation, which is mass times acceleration. So first we have to identify all downward forces and their distances from the pivot point. So we have our painter's weight, which we denoted with W of P. So we've got our force times our mass of the painter times G, which is 48 times 9.8, and we get 470.4 newtons. Then we've got our distance, which is 1.2 meters as denoted in the problem. It tells us that the painter is 1.2 meters away from the left support. And then we want our clockwise torque, which is our force, 470.4 newtons times the 1.2 meters, and we get 564.48 newton meters. Now we're going to identify all the downward forces from the right support. Now we need the scaffolding's weight. So that's WS. Same thing, we've got our force, which is our mass times our G, so 28 times 9.8. And we get 274.4 newtons. And then our distance is our total scaffolding length times 1/2. So we can find the center point, the center of mass of the scaffolding. So that's the 3.8 meters times 1/2, which is 1.9 meters. Then for our clockwise torque, we multiply the force times the distance, and we get 521.36 newton meters. Now we identify the upward forces, which is the counterclockwise torque. So we have our force of the right support, which we're trying to find, and the distance is the total length, so that's 3.8. And then our counterclockwise torque is the force of the right support times the distance. Next, we're going to set our torques equal to each other. So our total torque of counterclockwise is equal to the total torque of the clockwise. So our counterclockwise, we've got the F of R times 3.8, and we set that equal to the two torques that we found because we're finding the sum of the clockwise torques. So the 564 is from the painter, and then the 521 is from the scaffolding. And then if we simplify that a little bit, we get 1,085.84 newton meters. And then we divide by 3.8 to get the force of the right support alone. And we end up with 285.747 newtons, which if we round that to 3 sig figs, we get 286 newtons.